Hi, everyone, and welcome to the workshop, A Deeper Look into $W. My name is Tom. I've been working at Wix for the past 10 years, and I'm a tech lead at Velo. My background is actually not in software engineering at all. I studied philosophy and psychology, and I'm a self-taught programmer, as I'm sure many of you are as well. In my free time, I love to play chess, and I also play poker. Let's go over our agenda for today. We're going to talk a bit about programming paradigms and understand what they mean. We're also going to take a special look into $W through this lens of programming paradigms. Then I'm going to introduce to you a few declarative libraries, and we're going to do a workshop in which you'll get to experiment with these declarative libraries. It's going to be fun. So let's start by talking about programming paradigms. What is a programming paradigm? Well, this is the Wikipedia definition. Programming paradigms are a way to classify programming languages or frameworks. Now, if you Google programming paradigms, you'll immediately find this division between imperative and declarative programming paradigms, and I want to talk about that a bit. I find that the best way to actually explain imperative and declarative is not to speak about programming at all. So let's talk about scrambled eggs. I have a 6-year-old daughter, and she loves it when I make her scrambled eggs. Let's take a look at how she would do that. She would tell me to make scrambled eggs in the imperative way. Well, in the imperative way, she would tell me to open the fridge, take out 2 eggs, open the drawer, take out a bowl, break the eggs into the bowl, stir, take out the frying pan, turn on the cooktop, place frying pan on the cooktop, butter the pan, pour the eggs, scramble, etc. This is the imperative way. In the declarative way, which is, by the way, my daughter's preferred way of saying it, she would just say, "Hey, Dad, make me some scrambled eggs." Now, as you can see here, imperative is all about the how. Basically, my daughter is giving me an exact prescription of every step that I need to do in order to make her scrambled eggs. While the declarative way is all about the what. She just tells me what she wants, and it's my job to get it done. Also note here, though, that this is kind of misleading, because when she tells me to make scrambled eggs, I actually need to perform all of the steps that are in the imperative column here, right? I need to open the fridge. I need to take out 2 eggs. I do have some freedom to do it in a different order. Maybe I won't use a bowl, but I'll use something a bit different. Maybe I'll use 1 egg instead of 2, but I still need to do everything that is listed in the imperative column. And this is an important thing to note, and we'll understand why later. The same exact thing goes for programming. The declarative way of programming is just to describe what the program should do. In declarative programming, we say what we want. Whereas in imperative programming, we start how the program should do something. Just like in the scrambled eggs, we prescribe every step, what exactly needs to happen. Now, let's take a look at a JavaScript example. Also, if you Google declarative versus imperative in JavaScript, you will immediately come across this kind of example. Let's start by examining the imperative. So we have here a function that doubles each element. So basically, it accepts an array with numbers, and it returns a doubled array. So if I have 1, 2, 3 in the original array, it should return an array that has 2, 4, 6. Let's take a look at the imperative way. So in the imperative, we first create a new array called result. We then iterate over the items in the original array, and we push to the new array the result of doubling each item in the original array, and we then return the result. So you can see here that just like we saw in the scrambled eggs example, we basically prescribe everything that needs to happen in every step of the way until we return this array. Now let's take a look at the declarative one. We use the built-in JavaScript math function on arrays, and we just say array.map and double the item. We don't really care here internally how JavaScript does this, if it does it by a loop or in any other way. We basically just describe what we want to happen. And this is declarative programming. Also notice that it's much shorter, which is also a property, often a property of declarative programming. Now let's do a short quiz. It's going to be a bit tough doing this through video, But still, pause the video and think to yourself before moving on to the next slide. We have here an example that looks at a like button. You all know the Facebook like button behavior. It starts off as gray when you did not like something. When you press it, it becomes blue. And if you press it again, it becomes gray again. So let's take a look at this code, a possible implementation for the like button. If the state is liked, we render blue. If it is not, we render gray. Do you think this is declarative or imperative? And maybe pause the video here and answer that to yourself before moving on. Now let's take a look at another possible implementation for the exact same behavior. So here we have another render like button. If the user likes, we say that if it currently has blue, then remove the blue and add the gray. Else, remove the gray and add the blue. What kind of code do you think this is? Is it imperative or declarative? Well, as you can hopefully obviously see, this code is very much imperative, whereas this code is declarative. Note how in this code, we don't care how the transition between blue and gray occurs. We don't care what the previous value was. Whereas in this one, we care exactly about that. We prescribe exactly what needs to happen, how the state transition occurs. If it was previously gray, then you need to remove the gray and add the blue. Now let's get back to $W. So first of all, what is $W? $W is very much inspired by jQuery's famous dollar function. It's a function that accepts a selector and returns a Wix element. Now, from your experience, would you say that $W is imperative or declarative? And again, I strongly suggest you pause this video and ask yourself that, and only then move on. Well, let's take a look at an example. Here we'll see a ToDo app. So basically, what you see here, we have this input that says what needs to be done. I write something, I press enter, and the moment I press enter, the to-do list is updated. Note the behavior that happens here when I press enter. First of all, we'll see that the input gets reset, right? It has no content again. The list gets updated. And note also the items left counter, the one here on the left, it also gets updated with the amount of items that are not done yet. Let's look at a possible implementation of this. So we use $W, we use the selector to do input, and we say that on key press, first of all, we ignore anything that we don't care about if the key is not enter and if it's not valid. But assuming that it is, we push a new item to the to-dos array. We set something called an input value to an empty string, and we then update the UI. So look at what we're doing here. We update the input value, we update the list, and we update the not completed count. Now, from what we just learned, would you say that this is imperative or declarative? Well, as you can hopefully obviously see, this is very much imperative because we describe exactly all of the pieces that need to be updated in our UI in reaction to this event. Let's take a look at another example now. So now it's the exact same app, but I want us to focus now on the items left counter, the one we have here. So when I add an item, we can see that it is updated. But note there are other cases in which it needs to be updated. Say that I mark this to-do as completed. It's also updated because it only shows the to-dos that are not completed yet. What if I delete the to-do? It also needs to be updated. So just by looking at this example, how many times would you say that this item is updated? Well, if you guess 3, then you are indeed correct. And let us see that. We have here a function that is in charge of updating this item, this text element, and we can see that it is called 1, 2, 3 times. So basically, any time that a new to-do is added, we need to call to update this element's UI. Anytime that an element is checked, we need to update this element's UI. And anytime this element is removed, we need to update this element's UI. Those are a lot of pieces in our code that need to know about the behavior of this specific element. Now imagine if I were to add another feature. I would add a button here somewhere that would mark all of the to-dos as completed. It would also need to be aware of this element. And this is a lot of places that we can forget to update. This is a lot of bugs that can occur and that we can miss. So my question to you is, can we do better? Is there a better way to do this? Well, I'm here today to tell you that we absolutely can. And I want to introduce you to some ways in which we can do that. The first library I want to introduce you to is a library called React Velo. It basically allows you to write React in Velo. React, for those of you who don't know, is a declarative front-end library, which is de facto the standard right now in front-end development. It's perfectly fine if you're not very familiar with React and you're mostly used to programming in Velo with what we currently have, which is $W. Later, I will send also a bunch of resources in which you can read all about React, and there's a bunch of stuff available online. Let's take a look at how you would program with React Velo. So first, let's look at a very, very simple component that we see here. We have here a container that initially has a background in one color, and when you press OK, the color changes. So let's look at how we would write this in React Velo. So we have here a piece of state that is initially set to green, and we have a function to change this state. We see here that we use the W namespace to select our components, and we describe them using JSX. So we have w.myContainer, and the style of it, the background color, is the background that is set in the state, initially green. Now note the OK button. This is the interesting one. When we click the OK button, we just set the background to red. The container automatically gets re-rendered and gets updated with the correct color. Note here the difference between this and the example we saw previously with the not completed count. Note that the OK button does not know about the container. It does not care what other pieces in your software care about the color, about this background state. All it does is set it, and whichever element cares about this can use it, and React will just take care of the fact that it automatically needs to re-render in case this value has changed. Let's take a look at another example in React Velo. So as you probably know, Velo has a special component called a repeater. A repeater is very, very useful, and it allows you to render lists of items. Well, if you also had some experience with programming in Velo and repeaters, you also know that coding them can be a bit of a nightmare. You basically have to handle the entire repeater lifecycle. When data is updated, you sometimes need to iterate over the items and do something in order to reflect the change in the data. And you need to do that all manually, imperatively. Well, and you also, if an item is removed, you need to clean it up, and you need to do a lot of stuff, a lot of places in which possible bugs can hide. Let's take a look at how you would do that in React Velo. So in React Velo, repeaters have a special render item render prop. What is a render prop? A render prop is just a function, and you can see here that it accepts the data item, and it returns basically the view of the repeater item. So we can see here in this list example, we have list, and each item, it accepts the data item, and it returns w.description, which is this piece of text that we see here, and it's the data description, and the status, which is the status that we see here. And that's it. Whenever the repeater data changes, this data will also be automatically changed. If an item is removed, no problem, it will be automatically removed. You don't need to worry about cleanup or about updating it manually at all. So let's sum up how React Velo works, and you also get a chance to play around with it later. In React Velo, you build the UI using the drag and drop editor that we're all used to. You then describe your UI using JS6, which is a syntax that you saw now, very similar to HTML. And then you basically just write normal React code as you would in any React application. So this is one awesome declarative library that you have and that you can now use with Velo. Another one is something called Velo and MVVM. And these packages, I should say, both of them are available in NPM, and I will send later a link that you can see and understand exactly how you can install them on your Wix site today. Velo and MVVM is also a declarative library, but it takes a bit of a different approach. The idea here is that you have an observable store. So, and this is what we call your view model. So you can imagine this as a live piece of state that you then bind your elements to this state, so that whenever the state changes, if an element cares about a relevant piece in the state, it will just get updated. And it will make a lot more sense now when we see it in an example. So let's first look at the exact same example that we saw the React Velo. Remember this nice container? Let's see how it would look in Velo and MVVM. So here we use Velo and MVVM's create model function to create a new piece of state that has the color green. The container, we then use the bind view function. Bind view accepts a nickname as a key, and it returns an object. It contains the value as an object that has the properties as functions. So the container has a color that is the color that is set in the state. Let's take a look at the OK button, which was the interesting one. So the OK button, on the click of it, it just sets the color to red. That's it. This update that you're seeing now, this is all the code that was needed in order to do it. So the OK button, just like in React Velo, it doesn't care about the container. If we were to add another element here that would display what the color is, that's perfectly fine. The behavior of the OK button would not need to change at all, because all the OK button is in charge of is setting this piece of state to the color red. That's it. Now let's take a look at the list example. So Velo and MVVM also deals with repeaters, and it does this by providing a bind repeaters function. A bind repeaters function, very similar to the bind view one. It just has also a special kind of property, just like the render item in React Velo. It has an item one. Item accepts a data item, and it returns also a bindings object. Again, a bindings object is just the key is the nickname, and the value is an object containing the properties as functions. And you will get some link to docs later in which you can read all about Velo and MVVM in more detail. So if we look here at the list, we see the item, the data is set to state.items, and we see here that each item has a description and a status, and the text uses the data item in order to show the right text. Now, let's say that we were to add functionality to this list in which you can update the description of something. No problem. Velo and MVVM would make sure that the text is updated live. You don't need to handle anything on your own, not removal of items, not adding new items, and not updating existing items. And this is all very, very powerful. Okay, so enough theory. Let's get our hands dirty a bit. So let's look at what we're going to do today. Well, we're going to do the famous ToDo App workshop. Basically, I just thought that ToDo is a really good application because everyone knows how it needs to behave. It's something that people usually use to onboard a new library or a new framework or any new paradigms. And that's why I think it will really be helpful for us to use this as an example to learn all of these libraries. So basically, what we're going to do now is we're going to build a ToDo app and we're going to experiment with some declarative libraries. And I have here a link that you'll also see in the comment section of this video, sorry, to a README that I created that basically sums up this workshop and has explanation on exactly what you need to do. It also has a link to a template. Let's take a look at this template for a second. I already have it open here. So as you will be able to see, this template has 3 pages, one called Imperative, one called React Velo, and one called Velo and MVVM. In all of these pages, most of the ToDo app is already implemented. Your task, let's see it now in action, is to implement 2 things that are not yet implemented. You'll notice here that when I added a ToDo, the items left counter did not update. And also, if we change the filters here, you will see that nothing happens. So in each of these pages, you will find a ToDo comment, actually 2 ToDo comments, that instructs you to implement the filter group behavior and the not completed count. This is your task. Now, the README that I sent, it will guide you in exactly how you need to do that. You have your step-by-steps, and you also have here, if you're interested, some hints that you can use and the solutions. Now, feel free to complete this in any order that you'd like, and get back to the video after you've started doing this. Okay, so hopefully you have completed the workshop already. And now I'm going to do a small summary. So we talked today about imperative and declarative programming, and I want to put them side by side now in order to really examine the differences between them. Let's start by talking about the programming style. So in imperative programming, we perform step-by-step tasks and manage changes in state and how they impact the UI. We really care. Always think about my daughter when she asks me to make scrambled eggs. She cares what I do in every step of the way in the imperative way. Whereas in the declarative way, we define some data structures, we transform them, and we describe the UI as derived from the data. We basically describe what we want to see, just like my daughter describes that she wants to see scrambled eggs on her plate. That's it. In imperative, our main task is to tell the computer how to do what we want it to do, which is a very noble and important task. Whereas in declarative, we just tell the computer what we want to happen, and we don't really care how it happens exactly. Our main tools in imperative are iteration, loops, conditionals, and function calls, whereas in declarative, we mostly use functions. The advantages of imperative is it's probably more familiar to you. It's flexible and it's very powerful. But the declarative is very easy to write once you learn it. It's readable. It's less code, less bugs, easy to change, and easy to add features. The disadvantages of imperative are that it's bug-prone, hard to read, and hard to make changes. Declarative is slightly worse in performance, and I will address that in a moment, and it sometimes lacks flexibility. So the question is this magic? Well, it most certainly is not. And that's what I wanted to say also regarding my performance remark. Remember what we said about the scrambled eggs. At the end of the day, when my daughter tells me to make scrambled eggs, I still need to do a lot of things. So in a way, declarative programming is just an abstraction over imperative. So you hide away all these details of how exactly to make scrambled eggs, and you hide them behind some function or some library. React Velo and Velo MVVM does exactly that for you. It hides and handles for you all of the complicated stuff so that you can just focus on what you want your software to do. And this is a lot of power. If you look into the source code of React Velo and Velo MVVM, I'll tell you a little secret. And by the way, you can look at the source code. They're available on NPM. The source code is fully available. You will actually find $W in there because that's all these libraries do. They abstract $W away from you so that you can think in a declarative way and describe what you want to do. Now, I strongly encourage you to go from here, experiment a bit with these libraries, learn some React, learn some Mobix, which is the library that Velo MVVM is built on, and just go and build amazing things with readable code and with a lot less bugs. Thank you very much, and I hope you enjoyed this workshop.